So what we're really looking at in terms of applications is how can we do that? How can we put together something that's going to allow farmers to use the waste products from their own farms to produce fuel to fuel their own operations out there. So part of what we're working on right now is we're hack engineering a system for making ethanol, the three processes, the starch breakdown, moving into the fermentation, moving into the distillation, that we can produce the entire system for less than $5,000 using 55-gallon drums as the fundamental. And the interesting thing we've come up with now is instead of kind of normally people are pumping from one barrel to the next and going through the whole process, what we're working on the engineering right now is a system where you use the same 55-gallon drum with a heat exchanger, with wraparound heat exchanger to heat and cool, because you have to vary the temperature through all the different processes to make the enzymes activate and everything works at a different temperature. But what we're working on now is, instead of pumping things from place to place, having different lids. One lid has an agitator to stir. And so when we're doing starch breakdown, we put that lid on. Then pull that lid off. Another one has an airlock for the fermentation process. And the third lid has a still column. And so all of these processes, and we think that it's going to make a real opportunity for farmers to very inexpensively go ahead and set this system up. Because one thing we realize, if we're going to have small entrepreneurs, it's got to be an affordable setup. It's got to be something that anybody can do and make it really easy. So that's kind of the exciting thing we're working on with our program right now. And we look forward to, and by the way, this green training thing that we're doing, the Biofuels Center of Excellence and the green building and the solar, all these, they're not restricted to New Mexico residents. Most of these programs we are going to be doing are 3 to 5 day, I guess the ethanol program, because we need the time for fermentation, it's 3 days on a weekend and then 2 days on the following weekend. The final Sunday is teaching people how to make the three different lids and how to put together the whole system for making ethanol. But what I was going to say is, it's not restricting Mexico residents. If people are interested in coming out for one of our training programs, we have to track you and try to help you get jobs doing whatever you're going to be working on. But it's green. If you go to the website greentraining.sfcc.edu, you can get all the applications and find out all about the programs we're offering. So people are welcome to come and check it out.
Say that one more time.
greentraining.sfcc.edu.
I had that on the final slide. So
okay.
There. Okay, the final module here is biogas and pyrolysis, and Nick Chamber is going to be teaching that course. And Nick, would you like to talk to folks a little bit about this? You can see the 10K gasifier here.
Yeah, well, both of these are kind of the biomass component of things, different than the biodiesel and ethanol and the algae sectors, being that we're kind of dealing with the chunky fuels. Wet and biological would go down to the anaerobic digestion applications, like food waste and sewage, manure, plant waste, anything that has the 30-to-1 carbon to nitrogen ratio. And then the things that are kind of above that go down the thermal and dry avenue, which we're all familiar with this weekend, wood chips and pits and rice hulls and things like that. So kind of covering both those things and really looking at the kind of the carbon cycle and the atmosphere to biomass flux that we all are a part of every day, and how that works and kind of what roles we play in that. There's some of the things there. I have a background working with Agua DOS. I don't know if anyone knows that. Him and Tom Reed wrote that handbook of downdraft engine gasifiers. So he's quite a character with the Santa Claus beard and great personality. So we've got some experience working on very similar, but not as well developed generator sets like that All Power has here. And so, basic things there. The digester stuff that this program's enabling us to do is to sort of kind of bring the Asian technologies, the Indian and Chinese kind of rural, domestic scale biogas digester applications, kind of bring them into an American marketplace where, not everyone's going to put their hand in a bucket of cow manure and swirl it around. and then dump it in their vessel. And so we're trying to bring some of the automation features that happen at the larger scales and some of the efficiencies into a very small and compact unit that actually could be applicable for domestic scale or, you know, restaurants, cafeterias, community centers, that sort of thing. So we're really trying to bring a unit down to the smallest possible scale, and that is going to be about taking 70 to 20 pounds a day, depending on the feedstock, based upon about a 1,500 gallon tank. And it's solar heated, keeping it warm to, you know, metabolic temperatures, and also PV, DC direct powered, being that we are putting on some automation features to increase efficiency. But I want it to be a net gain, you know, so whatever energy comes out of this unit is essentially a gain, and we don't necessarily have to plug the thing into the wall and have a draw on the auxiliary energy source. So that's exciting and will be happening very soon. So we're going to be using that as a training apparatus for, you know, the small scale to medium, and then it all applies, of course, to large commercial type applications. And that's, yeah, the basic biomass sector of the module.
So what we're trying to do here is look at all the different waste products, so-called waste products that are out there. Restaurant oil, food waste. 50% of our food gets thrown away, goes in the landfill. I mean, that's crazy. Wood chips. We've got mountains of wood chips at our transfer stations because we've had piñons die a few years ago, and you know there's all kinds of terrible things going on with the forests in the Southwest. So they're needing to be thinned. So we're going to have a lot of wood waste there. And then, of course, algae. That's something we can grow. We don't need to compete with food crops. And as I say, algae is the basis of petroleum, so we can make plastics, clothing, food for animals, food for people. It's one of the miracle foods on the planet. You can run it in vehicles as fuels. You can make ethanol from it, biodiesel from the algae. So by looking at all these different feedstocks and sources of energy and food, it gives us a whole different, I guess you could say, paradigm for civilization. You know? It allows us to really take control of our lives, you know, take control of our food supply, take control of our fuel supply. We're not going to be so dependent on big pharma and big oil and hopefully not big banks and all that bigness infrastructure. You know, we have to learn how to become more self-sufficient here. And we're throwing away a lot of valuable BTUs. You know, I mean, we shouldn't be putting these BTUs in the landfills. We should be putting them in our vehicles. We should be using them to generate electricity, and we've got to stop using fossil fuels. We've got to move away from the fossil fuels as soon as possible. And so there's no one single silver bullet here. You know, we think we need to look at all these technologies. And you know, depending on your local situation and your resource base, certain of these technologies will make more sense than others. And so what we're trying to do in this program is present people with the range of possible technologies that they could or you could deploy in your communities on a variety of scales. And we like that they can be done on small scale, community scale. Some of them, maybe the scale requires larger, you know, a scale larger than that. We don't know all the answers to that either. So we're hoping to give the students the tools to do the kind of financial analysis that they'll need to do to see if this makes sense for them as a business opportunity. So that's where we're going with all this. We haven't done this yet. We're going to start to kick this off over the next few months. The classes hopefully will start in late April, May, run through the summer, into the fall. Santa Fe's a nifty place to come and spend a little time. So we encourage you to kind of check out the website here. Let's see. Here it is. No WWs. It's just greentraining.sfcc.edu, Santa Fe Community College.edu. There's an application form on there, and I'm hoping to get these curriculum that you just saw up on that. It's pretty new yet. You know, it's going to be developing over the next few weeks. So that's what we got going on up there. It's pretty exciting. And we're looking forward to sharing our passion with the students and inspiring students to take this all to the next level, make it happen. We hope to see a lot of equipment from here, gasifiers, be deployed in New Mexico and the Southwest. We'd love to be kind of a center for showcasing the newer technologies there. That's what we really want to do. And be a support base for your technologies in the Southwest. We don't see a lot of dots on your chart in the Southwest.
Yeah, we need to make those happen.
Yeah, we need to make it happen. Right. So that's why we're here. We've got a lot to learn from you too, so we're really looking forward to it. I love the model that you're showing here, how you can get a bunch of ordinary folks together and develop technology on a small scale that people can use on an affordable level for a variety of purposes. So you're a great inspiration to us.
And keeping it open source.
Keeping it open source. It's really important. So we really thank you a lot for the work you do. It's great.